Hey class, today we'll be learning about Newton's third law of motion.
Wait, what?
It's 3 o'clock!
So Newton's third law of motion really has to do with the forces that are interacting between two objects. So let's take a little look and remind ourselves what we already know about forces. We know that forces are interactions that has to happen between two specific objects. So sometimes it's pretty apparent what those two objects are, and other times it may not be as clear. So we have to make sure we identify what the two objects are of where this force is interacting. And that's including both contact type forces where the objects again are physically in contact with each other, or action at a distance forces, forces like the force of gravity or electric or magnetic fields. Now, you've probably heard Newton's third law of motion referred to as for every action, there's an equal but opposite reaction. And while that is true, it's a little hard to understand. It's not quite as clear as what really we want to focus on Newton's third law is. It's really the forces that are causing those actions. So for a force of objects, let's say there's two objects that are interacting with a force. The force from object 1 acting on object 2, F1 sub 2, is going to be equal in magnitude but opposite in direction when we looked at it from a vector standpoint to the force from object 2 acting on object 1. The idea here is that there's always a force pair or force couplet, and this always there. So for any one force that you're aware of, there's going to be this equal but opposite in direction force that's tied to that other force. That's the force pair, force couplet. That's really what Newton's third law is all about. It's also sometimes referred to as action-reaction force pairs. And again, the key here is not that there's one force that happens and then the reaction force happens after that. Really, these forces are happening simultaneously as these two objects interact with each other. Let's take a look at a couple examples. Now, as Maddie and I collide, you'll be able to see Newton's third law force pairs in action. The red force is the force that I apply to her, and the yellow force is the force that she applies to me. Both equal in magnitude but opposite in direction at the same time. But as you can see, that her mass is different, so even though this force is equal in magnitude, it clearly creates a different acceleration. Now, when Will and I collide here, we're going to collide with a lot more force, but our masses are closer to each other. So the impact of that force, again, equal and opposite in direction, are both felt here with both of us accelerating in the opposite direction we were going. Let's look at the example of a hammer and a nail. When the hammer strikes the nail, it applies a force to that nail, indicated by the red vector. But the nail also applies a force equal in magnitude, opposite in direction, back on the hammer. Evidence of these two forces can be seen as the nail is being driven into the wood, and the hammer, which is traveling downward, experiences a force upward, ultimately an acceleration in the upward direction, stopping its downward direction. For objects that are in static equilibrium or not accelerating or not moving, Newton's law still applies. As I push on the house pushes back equally on me, just in the opposite direction, demonstrating Newton's third law. So just to recap, remember that Newton's third law has to do with the forces and the force pairs. It's always between two objects that are interacting, causing these forces, and that they're going to be equal in magnitude and opposite in direction. Thank you, and I'll see you soon.